So as we are going to start FTD course, Firepower course. So before starting this course, let me show you the course curriculum or course index, like what exactly we do cover. As I told you before with Shiri, in this course, okay, let me show you the content first. So this Firepower course is part of your CCNP exam. And in CCNP, we have a one exam, which is core exam. One first exam is core exam S core. S core is basically 350,701 S core exam, and it's implementing and operating Cisco security core technologies S core. It's a kind of mix up, like it do cover FTD, ASA as well. It do cover your ICE, everything it do cover, and fundamentals of cybersecurity. That's a detailed syllabus of S core. But let's
Mm-hmm.
say if you want to do specialization, if you want to learn one technology in depth, then we have a concentration exam. So multiple exams are available. So the very first one is Firepower, Cisco Firepower Next Generation Firewall. So SSNGFW, that's our course basically. And another exam you will see here, that is 30715, Cisco ICE, Identity Service Engine. So that is another exam. And if you want to specialize in email security, so you can go with this 720. And if you want to go to here in web security, then you have a 725. And if you want to be specialized in VPN only, then this is the course 730. And last one is regarding automation for security. So guys, the course which we are going to learn here, it's part of CCNP. CCNP S core, and if you see the course list here, so it's a concentration exam, one of the concentration exam of Cisco.
Can you go a little bit out, please?
1 minute. Up.
Uh, yeah, that's the one. So in this course, hang on. What's happened?
Mhm.
It's disappeared. Nothing in the page now.
Now,
Yeah, okay. So in this course, you are going to cover the securing network with the Cisco Firepower Next Generation Firewall, including IPS as well, or just only the firewall?
IPS also.
Okay, so literally, after finish this course, we should able to do the exam for 300 something, right?
Yeah, exam you can do, but to get clear your exam, you should follow the dumps, latest dump.
That's fine. Okay, so I'm just saying, like, covering the topic of these two will be cover that exam. Okay.
Yeah, exam you can cover. And let me
Yep,
show you the
that's
detail course, like what exactly we have to cover.
yep.
Means what all practicals and whatever content we have, that I'm gonna show you.
Yep.
So I hope you guys are clear with the exam and all. So S core is the main exam, and if you do want to complete your CCNP with specialization, then you can go one course which is mentioned here. Among
Yep.
these courses, you can select one course based on like requirement. So this is your securing network with Cisco Firewalls. 307.10. 307.10.
Yep.
And now here, what exactly we have to cover? We have to cover these things. The very first thing is deployment, routed mode, transparent mode, NG IPS, next generation IPS, high availability, high availability options, static route tracking, clustering, failover, port channel, all these we can cover. And in configuration, we can cover policies, access control policies, intrusions, malware, DNS, URL filter, identity, decryption, pre-filter, all these. And apart from that, we also have to understand FMC. So FMC is basically your manager. Let's say we have a multiple firewalls and we want to manage all firewall from one single place. So for that, we use FMC. So FMC perform network discovery, and then it will allow to add your firewalls, and it do provide a visibility at single place, object management, rules management, NATing, device management, certificate routing. All these we will see based on FMC. And last is management and troubleshooting. So management and troubleshooting will cover your packet capture, packet tracer, and your packet analysis, in-depth packet analysis. All these we do cover in this. So basically, if you see here, so this is my exam code for Cisco Firepower, and the detailed content which I've shown you, that's we do exactly cover. But what I'm going to do here, because if you guys are already aware about ASA, then it's fine. Otherwise, a few things I will explain regarding the ASA as well in starting. Because those who do not aware about ASA, if they are going to learn FTD, so it's a bit confusing sometimes. So that's why I do cover ASA also in first 2-3 sessions, so that we get to know the legacy firewall of Cisco, like how it do work. Because CLI of FTD is almost CLI for troubleshooting of FTD we use based on ASA. So those who know, it's good for them. So what
Um, uh,
exactly? Yeah.
you can go through quickly for the ASA because we have been working on ASA for a long time. So the ASA CLI method we do work, but you can go with very quickly. I don't think we need a 3 section for the ASA, but you can go quickly for the ASA.
Okay, you guys are
No,
already know.
no, I don't know Selva.
Oh, you don't know the
Okay.
ASA?
Yeah, no
Shri,
works.
Shri, you also used to on ASA. You were telling on Palo. You are working on Palo Alto,
Palo,
as you
yeah,
told.
working on Palo, yeah.
ASA, you know.
No, I don't know. Never worked with ASA.
Okay, no worries. So what exactly we do? We do start with like a bit fundamental of ASA, then we'll move to here on FTD. FTD, FMC, and NG-IPS. So these are the core topics and core things which we have to focus.
Okay.
Let me quickly introduce about the ASA. So ASA is the traditional firewall of Cisco. If you come to here on the history of firewall, so you will see like in starting Cisco having a firewall which we called PIX firewall. So PIX is a Cisco product which we actually use for VPN and network policies as well for NATing in early days. So let me show you the evolution of firewall, like how the firewall they developed at different stages. So we get to we get a details about the history as well. We understand the different products as well. So this is NGFW evolution. Earlier you will see we have a VPN devices. So VPN is dedicated device which we use for VPNs only, for VPN configuration, VPN management, like remote access VPN, side to side VPN, all VPN things we were doing here in early stage, ancient history of Cisco firewalls. And we have a firewall which we call PIX firewall. So PIX firewall basically we use for the security and policies. In early 2000s, we were using this. In 2003, 4, we were using PIX and VPN concentration devices. And after that, Cisco just combined these two products and they provide a new product which we called they 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 developed a new product which is ASA. So ASA is your adaptive security appliance, which is basically combination of your VPN and PIX. Parallelly, they were developing Firepower, and after that, you will see they introduce initial configuration or initial integration stage. So at initially Firepower services we were getting with ASA, like we were getting IPS service along with ASA, IPS module we were using, and later we'll see the deeper integration, and in deeper integration we have a dedicated box which is FTD, Firepower Threat Defense. So FTD is basically having the features of ASA firewall as well, all next generation features like we get application URL filtering, everything we get here in this FTD. VPN netting, security policy, SSL encryption, decryption, IPS feature, everything we get within this FTD. So FTD having different models like 9300, 4100 series. And Cisco also developed a Firepower series, which is now we'll not see, but earlier it is another security product which we call Firepower. So 7000 and 8000 series they developed. And all 5500 series belongs to Cisco ASA. So here we are going to start with the ASA and we'll understand few things about few fundamentals and configuration things regarding ASA so that we can correlate in FTD. So if I do talk about ASA firewall, so ASA is your traditional firewall which basically focus up to layer 4. Means ASA function is up to layer 4 mostly. It can perform few L7 functions but not like modern or next generation firewalls. ASA is based on security level. That's the main thing about ASA. It's a security level based firewall. So let's say we have multiple interfaces here in ASA. Let's say this is my Ethernet 1x1 and it's my WAN link. And this is my LAN link. And that's my DMZ. One by two, 1x3, 1x1. So we have a three interfaces here in ASA, and 1x1 connecting to internet, 1x2 is connecting to LAN, 1x3 is connecting to TMZ. So what ASA says, like all interface we have to define with security level. So the interfaces which belongs to untrust, it says you do assign security level which is low. So security level basically we define based on the IP, based on the number. So we have a number which is from 0 to 100. Any number we can assign here on ASA to define security level. So let's say if you want to assign number for your WAN link, so we can give the lowest number here. Like I'm going to assign here 0, security level 0. So if interface is untrust, you can assign security level 0. If your interface is trust, so you can assign the security level 100. And for DMZ, we assign the security level 50. That's a default like security level assignment for ASA, which we see. So what happened here? If any traffic which is going from high security level to low, high to low, it will allowed automatically. It will get allowed automatically. Means without ACL, it will get allowed without policy. So let's say LAN users want to go to on WAN, so everything get allowed just because of high to low. Traffic is flowing from high security level to low security level. Similarly, you will see the next thing here, which is low to high. If any traffic which is coming from low to high, it is denied. By default, it is denied. It's not allowed. So low to high, high to low. So high to low means it's allowed. Low to high, it always denied and required ACL to allow. And for DMZ links, we have to always make sure it should be the security level of DMZ should be less than your LAN security level. So in a LAN, if you're using 100, so you can use here 90 as well, 90, 40, 50, whatever number you want. And it's
Just
not
question.
necessary. Mhm.
For a high to low, so that means we no need to write any policy. So that means it's unsecured, no? So from the high to low, that
Mhm.
means we no need to write policy, no? We no need to write any security policy, anything. If you set this number, it will allow by default.
Yes, that's a basic of ASA. But now question
Okay.
comes if you want to control this behavior also. So how we can do control this?
Okay. Yeah.
Silva,
But
what we can do
actually,
here?
use case is like, if you are sitting on internet network, you want access everything in outside, but you don't want to allow anyone untrusted people inside, right? So that's the
No,
use
he's
case.
saying like if particular interface is part of LAN, which is
Yeah,
your trust interface, and it's part of let's say WAN. So LAN to
yeah,
WAN, everything get allowed in this case, correct?
yeah, 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 yeah,
Whether it's
yeah.
port 8443 or any port, everything get allowed. So the question
Yes.
is how we can control this behavior.
That's again, we
Yeah.
need to put policies, right? So the default is like, no implicit deny on here.
Yeah. So what we can do, we can create a policy like we do put a one ACL here at last. If you want to control IP any deny. So it says like everything get denied, and at the above, then we can allow IP 443, 80, and 53, like whatever ports you want to allow. So even though security level we have, but if we do put ACL here like this, and I can put ACL here on this interface, or we can also put ACL here on this interface. So I can apply for the in whenever traffic in here on the interface. If these ports or these ports matches, then it should allow rest all traffic denied. So that's how we can control high to low behavior also in ASA. But if you see the default security system, it says high to low, everything get allowed. And if any traffic trying to come to from DMZ to LAN, so it's not allowed in this case. But from LAN to DMZ, it is again allowed. So that's a default behavior of your ASA. Nowadays, no firewall will work like this. All firewalls mostly work based on the ACL, and they all have a zone concept. From one zone to another zone, we have to allow the policies, and we do segregate our interfaces based on the zones. So we do configure multiple zones, but it's a traditional firewall. So these things we see.
But the zone based one is the one was introduced in from the ISO devices, right? So again, we are coming back to the same zone based firewalls.
Zone-based firewall is Cisco ASA is also zone-based firewall, but people do not use. Here also we can configure zone, but
Okay.
in real time we see this. Zone-based firewall is basically started in early with everything whatever we have in firewall basically started by Checkpoint. So Checkpoint, you can say father of firewall. They started everything, stateful inspection, management concept, and whatever we have a firewall like nowadays, it's almost everything originated from their Checkpoint. So zone concept they also introduced, and interface-based firewalling, anti-spoofing, everything we see normally it's come from Checkpoint. Checkpoint and Juniper started the zone-based firewalling properly, and then FortiGate. FortiGate also have a zone concept, and your check Palo Alto. Palo Alto is totally zone-based firewall. But in ASA, we do not see any zone concept normally. But yeah, option is there. Routers also can have zone concept. iOS devices, if let's say you want to configure router and you want to implement security based on the routers, then you can go with the zone concept. So zone is
Cisco
basically.
started
Mhm.
Cisco started the zone based in the iOS first, iOS devices. Then they came up with the Pix and the firewall. Yeah.
Yeah, in iOS or router, I think Cisco started, but firewalls already have this concept.
Hmm. That's okay.
So I hope you understand this. Now in FTD, we do not have these things. In FTD, we do not have high security level and all. FTD is almost like your next generation firewall, like other firewalls we have. So here you see the commands and all, which is totally based on ASA. Whatever commands basically with troubleshooting, for troubleshooting we run in FTD. Most of the commands based on like ASA. So if you see here security zones and all, like interfaces, so you always see security level concept as well. You also have to assign the name of interface. Let's say we have a security level for 1 by 1, which is 0. So we also have to assign the name. So let's say I'm using the name here, which is outside or untrust for the WAN. So to assign the name, we have to use nameif command. Nameif, and nameif when used to assign the name for particular interface, like inside, outside. So that's also mandatory component in ASA. Similar type of thing you will see in FTD also. It will ask to assign the name of the interface. And also you will see the zone assignment. So in security, in ASA firewall security, you will see concept of security level as well nameif. These two things mandatory: security level assignment and nameif, or we called it name assignment. So for all interfaces which is participating here in ASA, we have to assign nameif as well security level. Security level number you can adjust as per your understanding. Like I can configure outside interface with security level 10, and here I can say 20. Here I can say 15 also. This will work still. So this is the highest,
If you make,
and this is the second highest, and this is the lowest.
If you make a same security numbers, right, level, it means it's allowed everything.
If you configure same security level for two interfaces, so it will not allowed anything.
Not allowed anything.
Yes.
Okay.
Then if there is a same security level of two interfaces we have in ASA, for example, we have a two interfaces, Ethernet 1 and Ethernet 2. And both have a same security level. And I want to communicate A to B. Then by default, if you have a same security level for two interfaces, it will not allow any traffic. It will drop. So to permit traffic, which is having same security level, we have to run the command, which is permit interface.
Yes, that's a global command, yeah?
Yes.
Yeah, I do remember. Worked some 10 years before.
Inter-interface traffic and intra-interface traffic we have to permit. So if it belongs to same interface, then we have to run the intra-interface. And if traffic having different interfaces, then we have to use inter-interface. Intra-interface traffic look like this. If let's say this is my outside interface,
that's a U-turn traffic, yeah?
U-turn traffic, or you can say a kind of traffic which is working like hairpinning. So in ASA we call it hairpinning.
Yeah.
So let's say I'm using remote access VPN and it's a full tunnel, all traffic going here on WAN interface, and then again it is going from ASA to internet. So this is your U-turn, and that's we call intra-interface traffic. So for that we have to permit the traffic, then it only work. So that's how your ASA work. So till we understand the fundamentals like ASA security level can have a number from 0 to 100, and you can configure it based on your requirement. Another component which is nameif. Nameif is to assign the name for your interfaces, LAN, inside, outside, whatever name you want to assign. And last thing is your same security level traffic. It can be intrazone or interzone. So if the same thing I'm doing in Palo Alto, so what happened? If I'm trying to firewall, let's say this is my Palo Alto firewall and this is Ethernet 1x1. I'm trying to ping from this PC to this interface. So it's a part of intrazone traffic or interzone?
It's a interzone.
It's interzone or intrazone?
Intra. Same network.
Same network.
Intrazone.
Yeah.
So it's part of intra, not inter. Intra means it's the same. It's the same zone. So if I assign this interface in LAN zone, so traffic going into LAN zone only. It's not going to any other zone. So what happened here in your ASA? ASA will not allow any intra or interzone traffic. But if you see in Palo Alto, So intra-zone traffic is by default allowed, but it's not provide log, and inter-zone traffic is denied. Here, everything denied. So that's a basic fundamental of ASA, which you know, then it's good. Now let's try to understand the FTD things. So first, I would like to explain all the theoretical things which is required to understand your fundamentals. Then we'll move to the tactical. So if I do compare CLI and GUI and deployment of your firewall, next generation firewall. So what is, guys, difference between next generation firewall and normal firewall, NGFW? If I'm saying like Cisco Firepower or your FTD is next generation, so why we called it next generation? What all features we are getting here in FTD, which makes it next generation?
All the IPS and tradition, everything is in the same pack, right?
And so these features we were getting in UTM also. You guys know about UTM?
No.
Unified Threat Management. UTM boxes also available in market. So before next generation, we were using actually UTM boxes, Unified Threat Management. So UTM also having features like IPS, URL filtering, application control, all these. But nowadays, UTM is part of your NGFW.
So previously, the UTM was in a separate module for the
Yes,
ASA
yes,
firewall,
yes.
right?
Not
Like a
ASA
CS.
firewall, for all firewalls, like they have a different series with UTM. All
Yeah, so
firewalls providing.
for the Cisco
Nowadays,
firewall used the CSS model or something like that.
yes,
URL
yes,
filtering and everything. Okay.
module based. But nowadays, you will not see this UTM anymore. You will just only see this
That's the next generation. Yeah.
NGFW. Because NGFW now consisting UTM is part of NGFW, means whatever like URL filtering application control functions we have, that's now part of your NGFW. So what exactly we do have in NGFW? NGFW perform inspection up to layer 7, traffic inspection up to layer 7, layer 2, layer 3, layer 4, and application layer. Plus, it also do perform payload inspection. So at layer 2, basically firewalls can inspect your traffic, which is including MAC address, VLAN, as well. Firewall can inspect your traffic, which is if you see the Ethernet header. So here you will see VLAN tagging information, MAC address information, as well whatever like protocol you are using at layer 2. So that also you will see. Like if I'm using, okay, let me show you layer 2 header. Then we will see Ethernet header. So firewall can inspect these things at layer 2. Source MAC, destination MAC, length, data bytes, whatever we have, and your preamble and start frame. multiple things are there, but normally we see firewall will check CRC, data, source address, destination address. These things it will check in detail. There is one more field. Yeah. See, it look like this. Exactly what we see. So source MAC, destination MAC, and there is one field which we call ether type. So ether type also very important field. So this is also checked by your firewall. And if you are using any VLAN tag, so at Ethernet layer, you will see Ethernet tag also. So from firewall perspective, what do we see here? Firewall will check source MAC, destination MAC, VLAN tagging, if VLAN tagging is available, and then ether type. Ether type is a field which basically define a protocol which you are using at layer at the top of layer 2. Which protocol you are using at the top of layer 2? So at the top of layer 2, it can be IP version 4, IP version 6, MPLS, multiple types of traffic we can run. So protocol, ether type, and whatever the payload or length you have, that also payload or data and their length, whatever we have, that also we see firewall will check. So these all things we will see next generation firewall will check. And if let's say we have a IP header at layer 3, so firewall will check your traffic, which is for source IP, destination IP, IP protocol number, and your TTL value within layer 3 header. These things firewall will verify. So if let's say you are saying like this particular source should be blocked, or source IP, these source IPs should be blocked. So firewall will verify the source IP information from layer 3 header. If you are blocking any destination IP, so it will check from layer 3 header. If you're trying to block protocol numbers, then it also check the layer 3. What is protocol number? I hope you guys have idea about this. Port number and protocol number.
Sorry, what is that? Like, you're asking about the port number and protocol number for what? TTL?
No, protocol number. What is IP protocol number?
TCP, UDP?
So whatever protocols we run over layer 3, at the layer 3, at the top of layer 3, whatever protocols we run, whatever protocols we have, or whatever protocols we run, that is basically recognized by a protocol number. For example, if I'm running TCP at the top of IP header, so it do have a protocol number which is 6. It's a predefined. So if you block a TCP protocol number or TCP only, you block the TCP. So all the TCP based traffic get blocked because you are blocking TCP protocol, IP protocol TCP. Similarly, at the top of this layer 3, you will see the protocol which is UDP. And UDP is IP protocol number 17. UDP is based on IP protocol number 17. If you are using ICMP traffic or ping traffic, so IP protocol number is 1. So IP protocol number also recognized by firewall. TTL value is basically define the life of packet, like how long a packet can traverse. So normally if you generate from Windows machine, if your machine is Windows and you are trying to initiate any traffic, so the TTL value is basically 128. It's a operating system based. TTL value is based on operating system. And if Linux machine is there, then TTL value is 64 for the Linux. And if iOS devices are there, normally TTL value we see 255. So these all important fields which we see firewall will check in detail. Means
So the TTL value for the firewall is 128. That's what you said, right?
TTL value for firewall is based on the operating system. Normally Cisco firewalls will not uses the neither Windows or nor your Linux based. It's have their own. So
But in the
255 we see.
so like for example, right? I'm doing a trace route from my iOS router to outside of
255.
255. Is that TTL value will be changed
Yes,
when
yes.
it comes to the firewall?
If you are initiating, let's say from firewall, and it is crossing to, it is your host is here
Yeah.
after to router. So it will added your TTL value to 55. When it comes to here, it's become 254, 253. And when it received by this device, then it will see the TTL value, which is 253.
Yeah, that's fine. What I'm asking is, right, you said that the default value on the firewall, it's based on the operating systems. Is the FTD is running on ASA one, right? ASA is the iOS image, right?
Yes, so it will uses 255 if it
255.
initiate any traffic. Yeah.
So that means in the FTT's concept is a 255.
Yes.
Okay, cool. That's my question.
And if we do, if you see like, if you do trace any device or any address, that also we can verify. Like I'm tracing this. For example, it's a google.com. 1, 2, 3, 4, 5, 6, 7, 8. So here it is showing 8 hop count. And if we do ping it, so you will see here, whatever TTL value here you will see in ping. So that is basically your, based on your routers. So as of now, if I'm trying to ping this, so here we are getting TTL value, which is 60. So probably we are getting reply from Linux server. 46 minus 64 minus 60, so it's 4. So most probably for this ping, it is following 4 routers.
Hang on. So when you trace route, you see the 8 hops, correct?
Yeah, it is going from different path.
Yeah. So when you ping it, it's going different path.
Yes, that's why it is showing 64. Yeah, 60. And
So
let me see.
how do you say that the TTL value for that one is a 64? How do you say that? So before, because the 4 response, no, 4 response is not there, right? How do you say it's only 4 hop is
I'm
the
just probably guessing like, because I'm considering like it is 60. It is not gonna be 128, because to 128 it's required at least 68. So normally you will not see 68 hop counts for particular destination for these servers, especially Google and Facebook. If you are crossing 68 or 60 or 50 hops, then obviously will not get these much latency will get increased here. And I'm just getting here from 76 ms. So that's why I'm considering it. It must be your Linux, and rest. If I capture, then there will see that TTL value also. Then it get confirmed. Once you do capture, then you will see TTL value. For me is 128. For replying device, it must be 64. Like here, if I do run, Wireshark. So I'm just using this. So I've just applied ping protocol, which is ICMP. Now see, I've just here, we are getting reply here actually. Now it is showing 57. And here in capture, we are getting 8 packets because it is consisting your request and reply both. So I've just sent a 4 echo request, and in response to echo request, we are getting 4 reply packets. So if you see, source is 1.4 and destination is this 239.53. So that's my first packet. And if I show you here, so that is my layer 2 header. See, so firewall will see these things: source MAC, destination MAC. That's my ether type field. So ether type field is basically to recognize what protocol we are using. So if you're getting this value 0x0800, so it means you are using IP version 4 at the top of layer 2. So at the top of layer 2, we are using this. And now open it. And see, in the request packet itself, it is showing TTL value 128 because my machine is Windows. And then after ICMP packet, source IP, destination IP, everything here we have. An IP protocol number is IP protocol number for ICMP is 1. That's also showing here.
Just go to your command line. Sorry, your name, please. Sorry, I missed your name.
After
After
command line
okay.
also you can see. Now you can exactly check the here TTL value. Time to live is 57.
Yeah, if you
So
look
what
at your NS lookup with
here?
the tag, then you can see the TTL value for that one. I see the Google is 60.
Here,
Yeah, just put NS lookup.
okay, MS lookup.
Hyphen type. No. Just put like come out. NS lookup hyphen type. Yeah, that's one. Hit enter.
NS lookup is for name resolution.
No. Just check that one. Yeah, you'll see the TTL value.
1 second.
See the last line.
So the same we are getting in ping also.
Yeah. So that's the TTL value for the Google.
Now see, TTL value is 119. So it's
So
basically
that
dynamic. Whatever
dynamic,
the
right? That, because they're not
whatever the
using
nearest
static path.
server which is replying based on that, because nowadays we use Anycast technology. So Anycast along with DNS. So IPs change based on like Anycast, and it's always dynamic. So here it is showing that TTL value means we can reach with four with the four hops. It's 4 hops away. So that's why TTL value we are getting 660. Primary name server is this, and the record is here available. And if I do again, still it's 119 now. And from Windows machine, we can trace only up to 30 hops. That's it. It's not allow more than 30 hops. Here it will not show normally. So anyways, we were doing discussion about the TTL value. So I hope everybody get clear. TTL value is nothing. It just define the packet. If particular packet which is having TTL value 1 and it comes to firewall, then firewall will not gonna send that packet because TTL value 1, when firewall do -1, then it becomes 0. Or any packet which received by TTL value 0, firewall will not proceed.
Yeah, that's good to know because we are doing a MPLS network design, so that will help us to understand how the TTL value. Because in MPLS network we can play a little bit more on the TTL value.
Yes. In MPLS, it's based on your label.
Yeah.
Everything work based on the level. So there it depends like how you are using. So and here IP protocol number, TTL value, these all fields checked by your firewall in detail. Then it comes to here on layer 4. So normally at layer 4 we have a two protocols, which is TCP and UDP. So TCP is for the reliability of traffic, and if any unreliable traffic, so probably it's based on UDP. So we'll see like in real time traffic scenarios, we have a TCP and UDP based traffic. So if you want to control TCP and UDP port number or TCP and UDP ports or protocols, so we can control here at layer 4. So TCP headers and UDP headers will checked by a firewall at layer 4. And if TCP based traffic is there, so it will perform three-way handshake. It will always perform connection. It's a connection oriented. So there is two process in TCP. First is your three-way handshake to make connection, and another is four-way handshake. Four-way handshake is to gracefully terminate the connection. So three-way handshake always followed by SYN, SYNAC, and ACK. And four-way handshake FIN, FINAC, ACK, and last ACK. So finished packet or FIN we called. So these all things we see under TCP. So whenever it comes to troubleshooting, you will see if particular protocol which is based on TCP, so it always try to perform connection first. And once connection get established, then you will see the packets, rest packet will flows based on the connection or connection table. Similarly, UDP is not connection oriented. It's not maintain, or it's not going to maintain any kind of connection table or session table. So all the TCP ports we can control at layer 4. So let's say you are trying to block particular port
Cut off,
80443.
what is mean by FIN? FIN, you mentioned FIN, no?
Finish.
Oh, okay. Yeah.
Four-way handshake. If you want to terminate the connection, then so in TCP we called graceful termination or a tier down process. First, let's say client want to close the connection with server. So first it will say finish. Hey, I want to finish. So it will say this is the initial message, and in response to this, it will send acknowledgement fin act, and then it will say okay, let's finish it. So it will say here to client to finish, and then it will acknowledge.
So three-way is for establishing, four ways for disconnect.
Yes, four ways to tear down the connection
Yeah.
or connection termination. It's a graceful connection termination. Correct?
Yeah. Sync bit and fin bit is the one main player here. Sync is the one establishing, fin is for finishing the termination.
Yes. So on firewall, you will see logs also for these things. Stin,
Yeah.
fin, and it's
Yeah.
good to know.
Also, we are seeing that the server reset something different log. Server reset, that remote and server reset something.
What is reset? What does meaning of reset? So basically, reset means if connection or port is not open on particular device, so it will
Oh,
reset and close.
okay.
If you are looking for particular port which is not there, or it's not listening on that port, so it always say reset and acknowledgement.
So the firewall log format is defined on every vendor, right? So for the user friendly, they can do it. But if you do in the packet capture, you can see sync fin bit.
Yeah, normally Cisco logs, you will see it will shows closed connections or denied
Yeah.
like that. But in Palo Alto firewalls, you will see it's a good way, like whatever they are giving log. So if there is connection problem, so they will give you hint in a log with this incomplete.
Hmm.
So if you are getting incomplete message within the log section of Palo Alto, so it means there is three-way handshake problem. Devices or your client server won't be able to make a connection. There is issue of connection. There is something which is regarding connection. So you can troubleshoot for the connection. And if there is anything which is regarding insufficient, that is only in Palo Alto I've seen. And in other firewalls will not have this type of messages. So they also give a insufficient message. So insufficient means connection get established, but after connection, firewall won't be recognize your traffic. Means there's not enough packet exchange. Let's say I've just established the connection. After connection establishment, I've just exchanged one packet. So one packet is not good enough to understand the behavior or application, what application we are trying to use or what service it is going on. So in this case, it will say insufficient. So different firewalls have a different tactics or different methods to give or to give the hint in log or give a message in log. Normally in Cisco, we do not have a such method. It normally shows allowed or deny, or in some cases we'll see close or something like this. And at after this layer 3, layer 4, here we control all port numbers. TCP UDP port numbers we can control a layer 4. And all application inspection is done by here on layer 7. All application inspection take place here on layer 7. If let's say you are trying to use HTTP protocol or any protocol you are doing, so it's all being inspected here. You are trying to inspect, you are trying to run Facebook, Gmail, Yahoo. So all these application and their behavior is inspected by firewall at layer 7. So application inspection is being is being done by here on firewall at layer 7, and port number inspection or TCP UDP port and flags will check by firewall at layer 4. And layer 3 is your IP and your source IP, destination IP, protocol, TTL values. All these things we see here at layer 3. And layer 2 is MAC, VLAN, ether type. All these we see firewall will check at layer 2. So firewall is a device which inspect traffic up to layer 7. So nowadays all firewalls work on L7. Firewall is L7 device. It's not anymore L3. It's basically your L7. It can inspect traffic up to L7. Along with that, whatever actual data we have, let's say you are trying to download a file. So file is your actual data. So whatever actual data or payload we have, that also be subject to inspection. That also we can inspect on firewall. It depends like whether you are applying policy or not. So if let's say you have a antivirus inspection here on firewall, so firewall can check whether this file is clean or malicious. If you have IPS, so firewall can check the file whether it is having any script or not. Firewall can match against the signature. If signature says it's a clean, then it will give you clean log. So payload inspection also can be done here on firewall. So firewall comes nowadays with complete package. It can inspect up to layer 7 as well. It can also verify your payload, whether it's a malicious or whether it's a clean traffic. So NGFW is a firewall which inspect traffic up to layer 7. Why I'm saying layer 7 here? Because if you see the TCP IP model, so there we have a 4 layers only. And in packet capture also, we'll see the 4 layers. It will not shows like OSI model. Why? Because OSI model is just a blueprint. It's never used anywhere. It's never been used anywhere. It's just a blueprint or model. And the actual used model which we have, that is your TCP/IP. So devices also follow the TCP/IP, and it will always shows layer 2, layer 3, layer 4, and layer 7. Layer 7 consists your session, presentation, and application along with your payload. So whatever payload we have, it all be subject to inspection. If you applied inspection policies like IPS, if you applied policies like your antivirus, if you applied policies like your anti-spyware or some malware file inspection, so it's also be inspected. And when we combined all these features like IPS inspections, URL filtering, application control, and your IPS, antivirus, geolocation inspection, as well URL filter, application control. When we combined all these things together, along with layer 7 inspection, so it's become your NGFW, next generation firewall. Along with that, all next generation firewall perform stateful inspection also. Means we do configure policy at one direction. Stateful means we do configure policies at one direction only. For example, let's say we want to allow traffic from LAN to WAN. This is my PCA and there is server. And it's my LAN port and it's my WAN port. So I will allow traffic from LAN to server. So in order to allow traffic LAN to server, we have to create policy, which is LAN to WAN. Return policy is not required because whenever traffic goes from LAN to WAN, it will maintain connection table or state table. So connection table or state table will consist your source IP, destination IP, port number. It will maintain all the session information. And if the same session reply packet is coming, so it will allowed. I will show you during practical like how exactly it will work. So if you want to allow traffic, so you just have to make sure you create one direction policy. Similarly, if you want to allow LAN to DMZ, so you have to create LAN to DMZ policy. Whatever return traffic in response to request, whatever return traffic wants to come from DMZ to LAN, it will allow automatically based on the connection table. So firewall will maintain connection table or dynamic state table or stateful inspection done by the firewall. So when we combine these all features in one box, so it's become next generation firewall. And your FTD is fully F generation, fully next generation. Now let's do understand the deployment methods which we have in FTD. So we have basically two types of deployments in FTD. One we called standalone deployment. Standalone means you don't want to use manager. So let's say we have a FTD and we don't have a manager here. FMC is not there. FMC is manager actually. So FMC is not there, let's say. So we have a LAN, WAN, and PC. So if I want to access my firewall, here if I want to access my firewall, so there is two ways. One is based on CLI and another is based on GUI. So if manager is not there, so all the tasks we do perform individually on firewall for CLI configuration as well for GUI. So in Cisco ASA, we have a ASDM for the GUI. And in firewall FTD, we called FDM. And FDM allow access of firewall over HTTPS. Means over browser, we can access whatever IP we have. We can use over browser and we can get access the GUI of the firewall. So that's we call FDM access. So in a standalone deployment, we have a GUI method, which is FDM, and CLI is based on PuTTY, or you can perform SSH or whatever you want. So based on that, you can get access. And if you have a standalone deployment, so without manager, you are trying to deploy, so it will require individual device access every time. Next is your manager-based deployment. Manager-based deployment, or we called it two-tier deployment. It's based on two-tier architect. So here we have a firewall. Firewall is being managed by here manager, which is your FMC. And further FMC connected with internet and LAN here. And let's say DMZ is also there. Server, LAN PC. And this is WAN internet. Now we have to integrate this firewall into FMC. So to integrate the firewall, we have to establish the connection, secure connection between FMC and firewall. So that's
So
we
hang on,
called.
quick question before you
Mhm.
go. So the FDM, it's a firewall device manager. It's for the standalone firewall, right?
It's GUI access basically.
GUI access for the standalone firewall or
Yes,
any?
GUI access over HTTPS.
Okay.
It's not required any manager or any software like Cisco.
So if you want to use the FMC, that means it need to establish SSH because it will be pushing config and policies, everything, yeah?
Yes. So you have to establish first tunnel, or you have to integrate your firewall into FMC, and that's we call SF tunnel based integration, source file tunnel. So we have to integrate this firewall from any of the reachable port. A port which is reachable from firewall, that we can use. So let's say IP here I'm using 11.1 and here I'm using 11.1.1.2.
So we can use any ports or?
We can use any port which is reachable, any reachable port.
So SF tunnel doesn't use any specific ports.
Yes, hardware port we can use any, and it required TCP connection on the port 8305. This port must be open between firewall and FMC. If there is
Yeah,
any firewall between.
That's the Cisco requirement for 8305 TCP port, yeah?
Yeah, in between it should be open, then we'll see SF tunnel get established. And once tunnel get established, so we can configure the interfaces for FTD, we can configure the policies, we can configure the NATing, everything we can configure on FMC, and then we have to push it. We'll push to FTD. So that's your manager-based deployment, or we call two-tier architect. So everything we can control from FMC, routing, policy, everything.
But still, I can do the firewall. I can do the GUI based. Still, if I'm because we have the FMC, still I can log in directly to the firewall itself. GUI now.
Once you do integrate, so GUI is not available, but CLI you can get
CLI. Okay, yeah, no worries.
because everything get managed here. To just avoid the confliction, GUI is not available here normally. And CLI for troubleshooting and normal CLI commands we can run here on FTD.
So how this works, I'll tell you, like if you log, so for example, some troubleshooting, I'm logging into individual firewall. For example, I got 3 firewall managed by FMC, V20 or V2, whatever. So if I want to make changes on one of the firewall, that config changes on the one of the firewall from the CLI, is that automatically updated to the FMC? How that will be synced?
Reverse changes not applied.
Not allowed.
Yeah, not applied actually.
Then
Perform anything here
then what's the purpose having a CLI access? Only
for
troubleshooting?
troubleshooting to verify configuration.
Verify and debug?
Yes. Once you do integrate in manager, so it's highly recommended you will only perform changes from FMC or manager.
Okay, that makes good.
Because that's why we are using. If you're performing still from standalone, then there is no use of this. If you're still performing the configuration changes from individual device, so of course there's no use of this FMC. Why you are using this centralized device? So it will allow to manage and everything you can control. And here we have a separate policies. You can keep the separate policies for each firewall as well. So we have a different policy packages also. Policy
From the
package is a folder, kind of folder, which keeps the policies for particular location. Let's say for firewall 1, I have a policy package A. So all the policies regarding firewall A will keep under this folder.
okay.
Or you can also make us common policies. So it's up to you. You can group 2 devices and if let's say you want symmetric policies for 2 devices, then you can keep in a same policy package or same folder.
Srini, this is what we have to follow for our fusion layer. Yeah. So
No, we already done the same way. We have different policies set.
okay, so you put the device name in front of the policy name?
Yes.
Okay.
Yeah.
Okay, all right. I think we are good for day 1, and I hope you all understand the fundamentals. And tomorrow we'll do understand then practically things. And probably we'll have a session around 1.5 or 2 hours from tomorrow.
Yeah,
It
that's
depends
good.
on the topic.
Yeah, I'm happy to continue this. Again, from the we like to go more depth on the FTT side. Yeah.
Yeah, see, it depends on discussion. If you do discuss, I will do continue. Apart from that, whatever required things, I will definitely do in depth.
Yeah, we are doing more deployment on 4200 series firewall, 41 and 4215, 4225 as well, with the FMC V300.
Yeah, we can dig out whatever requirement is
Yeah,
there.
so
Like,
that's what one. And then we like to know more about the cluster setup and equal cost multipath, HF pairs. Yeah, these are the more main things we like to understand more deeply.
No,
yeah,
also fusion.
Yeah, fusion is the same policies as Srini. So the policies.
No. The VRF, all those stuff.
When you
From
say
the interface.
when you say fusion, there is no concept as a fusion. Fusion is defined from the business use case. When it comes to the firewalls, right, it's a policy enforcement, right? So we will be configuring the policies for basically what we might need to know how we will be segmenting the traffic, segmenting the zones inside the firewall. That's what we needed. That's what called as a fusion, right? So that from one segment to another segment, how we will be bleeding the traffic. That's the main thing we are going to focus. But let's see whether
yeah,
how
no worries. Being on the like once the session will started, once we keep going on the sessions, we'll more clearly understand like the policies and everything based on the scenarios we can do discuss cluster and everything.
Yeah.
Definitely, I'll do cover. No worries.
Yeah, we probably like I understand you covering the index of the book, so that's fine. But from my understand, for myself, and the Srini's focus is more on the use case and practical scenarios. That will
Yes,
help
yes, you
us to
can discuss with
understand
me.
more thing. Yeah,
You can come
yeah.
with
So
scenarios. We'll make here.
yeah,
Yes,
yeah.
the bottom one.
Apart
Yeah,
from that, we
just
have also. Yeah, yeah.
6th, please.
That's
Yeah,
will
because
be
I'm only struggling with the because all the logs, how we can view all the logs, everything. That's what I'm struggling now with this Cisco FMC. It's not like a Palo Alto easy thing.
how good are you for log interpreting, Afran? Like that's that you know in our environment we are looks like working more on the log side. You know, we will be checking a log and troubleshooting, and then what's happening and interpreting the logs, and
Yes,
then
yes,
find
we
out
can
what's the use. That's
we can
the main
do
things
understand
we are working
the things based on the log as well. Yes,
on.
definitely. Okay,
Yeah.
guys, all right. So let's meet tomorrow at the same time.